Alright, so welcome back to Mr. Yasuda's math videos. I hope you are having a great day. This video is going to be on graphing secant functions, but I do just want to say that if you haven't really watched any videos or learned how to graph a cosine function, then this way probably is not, or this function is not going to go very good since it's related to cosine. So I'd encourage you to do that. Go watch, I've got a graphing trig functions playlist. Go check out how to graph cosine. It also wouldn't hurt to watch how to graph cosecant, and then you might already be able to guess how to graph a secant function. So let's get going. Alright, so y equals secant of x can be graphed by first figuring out the points of y equals cosine of x, because if you think about it, cosine and secant are related. So I'm actually going to graph y equals cosine of x real quick. So not the best labeling job, but here's negative 2 pi, there's negative pi. Pi and 2 pi. Okay, and then let's just say that this is 1. So cosine starts up the amplitude, right? Then it goes down. And then I'll go the other direction so we can make 2 full periods. Alright, so here's your cosine graph. Okay, so think about your identities. Secant of x is equivalent to 1 over cosine of x. And since they're reciprocals, one could say that means y equals secant of x could be written as y equals 1 over cosine of x. So if we're trying to figure out what the graph of secant will look like, we could just do the reciprocal of all the y values of cosine, and then we would actually have the graph. So let's just start with the ones we know at the point. So the y value at this first point is 1, so we'll just have another point at 1. The reciprocal of 0 is undefined, so now at negative 3 pi halves, I'm going to have an asymptote. At negative 1, it'll still be negative 1. That's what the reciprocal is. At pi halves, though, right, I'll have an asymptote. This will be 1. That'll be an asymptote. This will be negative 1. That'll be an asymptote. Alright, and that'll be positive 1. And now what to do with the rest? If you think about it, what happens to values in between 0 and 1, because that's what these are, right? These values are in between 0 and 1. What happens to them when you do the reciprocal? Well, they get bigger than 1, and so the graph's actually just going to open up this way, right? And then this one will go down, and then this one will go up, and down, and up. Alright, I'm going to erase the red graph so that you can see just what a secant function would look like. Okay, and so there's our secant graphs. To do domain and range, it's not too terrible. The domain is not all real numbers. Remember, we're going to describe it with an asymptote. So this is negative, or just pi halves. So x equals, or can't equal, pi halves plus, and notice it's like half the period, right? So pi halves to 3 pi halves is pi, so pi n. And then the range, we're going to use the union. So that's going to go from negative infinity to negative 1 with a bracket. And then I'm going to do the union, and it's going to skip over those from negative 1 to 1. And so it'll just go from 1 to positive infinity. Okay? And so that's your basic secant function. I'm going to do 2 graphs in this video. I'm going to do just a basic transformations, and I'll do one that has like all the transformations. So if you've watched all my videos, you know this graphing form. D is going to do your vertical shifts. A is your amplitude and your reflections over the x-axis. I'm going to say something about B here. So remember, secant is related to cosine, and remember the period of cosine is 2 pi, right? So that's going to be the period of secant, and so the way we're going to do a period change, right? The way we'll do a period change is we'll do 2 pi, the original period, divided by B, and then the last thing I'll say is remember it needs to be factored in order to see the horizontal shift or the phase shift. Alright, so let's get going. We're going to do this one, basic transformations. Y equals -3 plus 2 secant of x. So the first thing I would say is to graph the points for y equals -3 plus 2 cosine of x, but don't connect the dots. Right? Don't connect the dots because it's not a cosine graph. Alright, so here we go. Let's get a nice axis here. There's no period change, there's no horizontal shift, so it'll be just 0 to 2 pi. So pi halves, pi, 3 pi halves, and 2 pi. Okay, and we'll go and do another one as well. So -2 pi, -3 pi halves, -pi, and -pi halves. Okay, so there are x values. We've got a vertical shift down 3, and then we're going to end up probably going 2 more at some point. Alright, so we're going to draw on our midline, right? And now we're going to plot the points. So here we go, points being plotted. Starts at 0, and it's going to start up the amplitude. That's what cosine does. And then I'm going to go down 2, up 2, up 2. Then I'll just continue the pattern. Okay, and we're not going to connect the dots. I wanted to connect the dots so bad there. Alright, then we're going to draw in the asymptotes, right? Since it's a secant function, it's going to have some asymptotes. And the asymptotes are going to be in the middle, right? Wherever it hits the middle, that's where you are going to put your asymptotes. So at that point, at this point here, at this guy, and there we go. And then if it's opening up, open the graph up, or if the point's above, make it go up, and if the point's below, make the parabola go down. And just nestle those curves right in between the asymptotes. Shouldn't need to find any extra points, just do that. Should be good. Okay, let's do the domain. The domain, right, x can't equal pi halves, that's one of the asymptotes, and they're separated by pi. The range, a little bit trickier, -infinity to -5, union, and then -1 to +infinity would be all the y values that are being used. Okay, so that's how you graph basic transformations. Let's put all 4 of them together. If you want, feel free to hit pause, try to graph this guy, y equals 1 minus 3 secant of pi halves x plus pi. You can hit pause now, and then you can watch the answer here in a second after you finish graphing, or you can follow along just to get a little bit more kind of understanding. So here we go, amplitude. I'm just going to break it all down since it's got a lot going on. The amplitude's 3, and I'm going to remind myself I should do a reflection. The period, a little bit trickier. Right, so we're going to do 2 pi divided by pi halves. So when you divide by a fraction, we're going to do the reciprocal and multiply, so times 2 over pi, that's over 1. The pi's will cancel out, and we'll just be left with 4. Our vertical shift is up 1. Alright, here we go. We've got to factor this guy in order to see our horizontal shift and know where our starting point is. So we're going to take out pi halves. We'll be left with x plus, and then let's think about it. What would that number need to be so that when I do pi halves times that number, you would get pi, and that number would have to be 2. And so we also now have a phase shift of left 2. Okay? And so with all that said, we should be able to graph this. I'm going to do a quick sketch of my x-axis. Here's the start. So it's going to start at the phase shift, -2. I'm going to add the period, so I'll get to 2. And then we're going to find our points in the middle. We can multiply our period by 1/4. So that'd just be 1. So that'll be -1, 0, 1. Oh, that worked out really nice. So nice x-axis for us. So -2 to 2, and we can do another one as well. Alright, so -2, -1, 0, 1, 2, 3, 4, 5, and 6. Plot some points. Well, let's get our midline in. It's moving up 1. Okay, it's moving up 1, and then we're going to plot some points. Remember, cosine is going to start up the amplitude normally, but since it's reflected, I'm going to start down the amplitude. Then I'll go up 3 to the blue line, and then up 3 again, then down 3, and down 3. Up 3, up 3, down 3, down 3. Okay, don't connect the dots. Draw in your asymptotes where it hits the middle line. All right. And then we will nicely make those curves. Hopefully you got the same thing as me. I'm going to say that the domain is x can't equal, and I'm going to roll with 1 plus, and notice they're spaced out by 2, so 2n. And then the range is going to go from -infinity to -2. And then union looks like 4 to infinity. Alright, hopefully that makes sense. Hopefully you got the same thing as me. And if you need to check out any other graphing problems or graphing trig functions, go check out my playlist on graphing trig videos. Feel free to like and subscribe. Hope you have a great day. I'll talk to you soon.